Hey, I know the deal. You get up in the morning, or you're just getting ready to leave work in the evening. You get in your car and turn the key. Already when you put the key in, you know something's wrong. Your theft light is flashing slowly and your bell is dinging slowly, and you go and start the car and it barely turns over. You hear a click, 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 click. So what do? Many shop manuals separate the charging system from the starting system, troubleshooting, and maintenance work. In this troubleshooting segment, I will combine them and look at the symptom of engine fails to crank or cranks slowly. The starter solenoid may or may not click. The reason I combine the two is because one component may misdiagnosed if you don't look at both systems. For example, just because the starter's clicking doesn't mean the starter's bad. So let's get started. If you have a fails to crank, or in other words, your engine does not turn over at all fault, immediately check the neutral safety switch on automatic cars and the clutch switch on manual cars. Is the gear selection lever in park or neutral? If you press the clutch, then press it again and ensure the pedal goes all the way to the floor. On automatic cars, press the brake and move the gear selector out of park and then back into park. Then try the key again. Well, if you're working on your own car, you probably can already do most of the first few steps, the checks, from the driver's seat because you've been driving the car. You know that the belt is on the car because your power steering wouldn't be working properly, and you would have heard the belt come off the car. You know that your alternator is turning and it's not making noise. You might also have a gauge that's a voltmeter that'll give you some indication of whether your alternator is charging or not. And you may have some form of light, like this battery light, that'll tell you that there's a fault in your system. But what happens if neither of those are on, or you can't tell from your gauge because it doesn't have enough resolution whether there's a problem or not? So what's the first thing you do? You have a buddy jump off your car, you jump start your car, and you head home. So once you get home, you need to troubleshoot what the problem is. So let's troubleshoot the problem. Most of these first few steps you can probably do from the driver's seat, but if you're working on somebody else's car, you can't do it from the driver's seat. You're going to have to take a look under the hood. So let's go look under the hood. So the first thing you should check once you're under the hood is your battery terminal clamps. Make sure they're tight and there's no corrosion on them, and that the terminals are all there, that they haven't been eaten away or arced out because they've been loose. So you make sure they're tight. And if you clean and service the batteries regularly, you should clean them once a year, you would know that that's not the problem. You check the wiring on the alternator. You don't smell anything that's burnt or anything that's out of place on the wiring. On this 4.6 liter, the wiring is right here, runs to the battery, and we're just checking for physical damage that runs behind the alternator. And while you're here, you're looking at the belt. The belt is still on and functioning. Like I said, if this is your car, you know that that belt is still operating because you wouldn't have power steering. You wouldn't have cooling, and you would definitely know when that came off. You'd hear a noise. So you know if this is somebody else's car, now you've verified that the belt is on and still functioning. The only thing is, on most cars, they now have a serpentine belt, and you can tell from this particular car, it doesn't have a lot of wrap on the alternator. So true, the belt could be slipping on the alternator, but you'd probably hear a noise. Sometimes you may not, but on some cars, you may not hear a noise, and the belt may be slipping on the alternator. So that could be an issue with an old belt. So you want to check belt tension, and on most modern cars, you have a serpentine belt that has a tensioner pulley on it. that maintains tension. So on a lot of cars that's not the case, but it's worth a check. So what's causing the click 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 on my starter? It's a low voltage condition, a low power condition to the starter. Is it a bad starter? Maybe. Probably not. It's probably either the alternator or the battery. So let's pull out our multimeter and check the battery. In order to know whether it's the alternator or the battery, you need to check voltage. And to do that, you need some form of multimeter or voltmeter. This is a cheaper Radio Shack version. There's lots of people that make multimeters. I like to use this expensive fluke meter most of the time, and I'll use this one in the video. But I also recommend, if you don't have a voltmeter, to get this inductive style meter so that you can also check starter amperage. You need the inductive clamps on the multimeter to be able to check the starter wiring and the starter load. But this one also does volts AC and DC. So this particular model is rated up to 400 amps. They make models that are up to 600 amps, but for automotive use you need one up to about 300 amps. So the 400 amp is sufficient, but the most popular are the 600 amp, but most of those are for AC only. So use caution when selecting a multimeter, because some are just AC only. What you need is AC and DC in amps, and you'd also like it to read volts in AC and DC. Well, for automotive use you need it to be volts DC and amps in DC. This meter also reads continuity, which is important for automotive troubleshooting, and you can turn on a bell, which is helpful, so that you can test grounds and check continuity on wires, fusible links and fuses. I'll link to this multimeter in the description, and also a fluke meter that's similar to this, and then also a fluke multimeter. But if you don't have a meter, I recommend that you get this style of inductive clamp meter. So if we just drove home and our alternator's bad and it hasn't been charging the battery, we probably have a low voltage condition at the battery already. So what we need to do is make sure we start with a charged battery. So we need some type of a battery charger, either a light little trickle charger like this, or a more robust charger, and charge the battery. So start with a full charge on the battery. Get out your multimeter. Set it to read volts DC. Connect your negative lead to the negative battery terminal, and your positive lead to the positive terminal, and read the battery voltage. This battery has 12.48 volts in it, which tells us that the battery is new and it has a full charge on it. Automotive car batteries have 6 cells in them, and each cell has 2.1 volts. So 6 times 2.1 gives you 12.6 volts is the maximum voltage that this battery would have when it's brand new. That would indicate it was a very new battery. So if this battery isn't too old, it's still got 12.45 or 12.5 volts in it. So we know that battery is good and it's fully charged. What voltage would indicate that this battery is bad? If it's either low charge state, if it's below 12, or if it's below 12, it's getting to be an old battery. If you put the meter on it and the voltage is dropping to where you can see it in real time here, if you can see the voltage drop, if it's going from 12.4, 12.3, 12.2 then there's probably a bad cell in this battery. Just reading the voltage on the battery gives you a really good idea of the battery state. But you can use something like this device. It's a battery load tester, and you simply hook up the leads to the battery, turn the switch on, and it has resistance coils in this device that heat up and draw the amperage out of the battery, and it'll tell you the battery state. I don't like using this because the way it draws down the battery and the way this device heats up. But you can take your car to most auto parts stores and they'll use a device like this on your battery in the car and check your battery state. What I like to use is a smart battery charger, one that tells me fault codes. So once you charge a battery, and you can select what type of battery that you're going to use, either a wet cell, a gel cell, or an AGM battery, and then you select the amperage, and as this charges, it'll tell you that when it's got a full charge, and it also, once it's put a full charge into the battery, if it can't complete its cycle and put a full charge in, it'll give you a fault code, and it'll tell you what kind of a fault your battery has, whether it has a bad cell or it needs to be reconditioned. This will also recondition a battery. But like I said, you can get a pretty good idea of the state of the battery just from a multimeter. However, we're not done yet. So what we want to do is start the car. I'm going to start the car. So once we've got the car started, now we're going to check the voltage again. This is going to indicate what the alternator is charging at. So this alternator is charging at 13.9293, which indicates it is charging. I would really like to see this charging a little higher than that, but maybe because the battery is fully charged, it doesn't need to. So that's acceptable, that's within range. It needs to be charging from 13 to about 15 volts DC. If it's charging more than 15 volts, that's indicating that the voltage regulator in the alternator is bad. It's probably overcharging the battery, which could cause the battery to fail early. So this particular car doesn't have a fault. It's got a good alternator and it's got a good battery in it. However, if your battery seems bad, another way you can tell if it's a bad battery, a lot of times there's a parasitic load from the car it's keeping things alive, like lights and your computer in your car and the stereo and all that kind of stuff. So there's going to be some load on the car. So what you can do is take the negative battery clamp off of the battery and then leave the battery sit and charge it that way. Make sure it's got a full charge, but then leave it sit for a period of time and then come back and read the voltage. You shouldn't see a drop, especially if the negative clamp is off of the battery. If you do find yourself with an overcharged condition on your battery from the alternator, most modern alternators have the voltage regulator inside the alternator. Like this alternator has a voltage regulator inside it. Older cars, like my older Mustangs, the 60s and early 70s Mustang, will have the voltage regulator over on the fender somewhere or on the firewall. In those cases, you can replace the voltage regulator. And on some GM models, the voltage regulator is on the back of the alternator, and you can replace that by itself. But most modern alternators, if the voltage regulator goes bad, it's designed to just replace the whole alternator. In the description of this video, I'll show how to replace this alternator. The alternator on the 4.6 liter Fords and the 5.4 liter Fords, they're all the same, they mount the same. I'll link to that video in the description. If you have a no charge condition from the alternator, before you replace the alternator, you should check the wiring to the alternator. Within the wiring to the alternator are fusible links. So check continuity to the alternator. We've been working a little while now checking the voltage at the battery and then from the alternator, And so far we've determined that our battery is fine. We have a good battery and we're getting the proper voltage from the alternator. We're going to move on to checking the starter. But before we do that, I'd like to show you that we could have done all this work from the driver's seat. Just a quick sidebar, if you've got a 13 Mustang like I have, under the gauge mode, there's a voltage indication. So here's my Mustang with the engine off that's been sitting for a while. It's got 11.8 volts in it, and so that's low, but this battery's never been changed in this car. This battery is 7 years old. This car was made in June of 13. So let's start the car. There, the voltage goes to where it should be, 14.2, 14.3. So the alternator is charging. Here's a second sidebar. If you put a voltage gauge in your car, make sure you're able to read it with the engine off, so you can read battery voltage by itself, and then also be able to read when the car is started so that you can read the alternator voltage. Then you won't need a multimeter. This is my 2005 F-150 Lariat that I show in a video how to install these gauges, voltage gauges with USB ports. I'll link to that in the description of this video. Okay, where were we? We charged the battery, made sure it had a full charge on it. We checked the voltage and made sure it was between 12 and 12.6, so we know we've got a good battery. We started the car, checked the voltage, and made sure that we were getting from 13 to 15 volts from our alternator. So now we need to check the starter. From here, we need to revisit the symptom. So we're talking about engine cranks slowly or fails to crank. We're not talking about if engine cranks and fails to start. That's something totally different. We'll have to do a separate video on that. But what we're talking about here is engine cranks slowly or fails to crank. If the engine fails to crank, we need to look at voltage at the starter. For starters, there's two basic starters. There's a new style, which I'm showing here, which most modern cars have. They have a starter with the starter solenoid mounted on the starter. So we measure battery voltage. This is the battery cable. You should have the battery voltage here all the time. So 12 volts to 12.5 volts at this position. And then as you're under the car, you need somebody to close the start switch, the ignition switch, and push in the clutch or make sure the car is in neutral to measure voltage here. If you have voltage in both of these places, that indicates that the starter motor is bad. If you don't have voltage in this cable, then it's the starter cable that's bad, and you need to troubleshoot why. So you can take that off, clean the ends, and measure resistance on this cable. So with this cable being bad, simply replace it. If you don't have voltage here, then you need to troubleshoot. So check fuses, the ignition switch, and then make sure you have your neutral safety switch or your clutch switch could be a problem. The second type of system is what Ford used to use. Chrysler used to use this. Jeep uses it. It's with a starter relay or a starter solenoid, and then the old style starter that only has one post going to it. You can measure the voltage to the starter here, but you can measure it coming from the battery here. So you should have battery voltage here, and then once you energize the solenoid, you should have battery voltage here going to the starter. And again, you can measure from the ignition switch here at this point. So again, this is for older cars. There's only one electrical lead. It's a battery cable connection on the starter, and then a starter relay that has two posts, and then the coil to energize to get voltage to go across the solenoid. On the starter solenoid style, if there's no voltage here coming from the battery, then it's simply that cable that's bad. If there's no power coming here from the ignition switch or neutral safety switch and clutch switch or clutch switch, then you need to check fuses and wiring here and then those two switches. If this solenoid pulls in and you can hear it click and you have voltage here and voltage at the, and you don't have voltage at the starter, then this cable's bad. If you do have voltage at the starter, then it's the starter. If the engine cranks slowly, then we want to measure the load or the current draw from the starter. The first thing we're going to do is locate the starter wire. I have two positive leads, two positive wires coming off of my positive battery terminal. One goes down to the starter right here, and one goes to this power distribution box. So here's the wire I'm looking for. I'm going to prepare my multimeter by taking the leads off of it. We don't need these two leads. We're not going to be measuring voltage. We're going to be measuring amperage. There is a voltage check that you can do at the battery for the starter, but it's much more accurate to check the load, the amperage that the starter is drawing to determine the starter life. I'm going to take my meter, open up the clamps, and insert it around that wire. I want my engine to crank but not start so that I can measure the amperage of the starter. So I'm going to remove the two connections to my dual pack coils. After I've got my two coils unplugged, I'm going to set my multimeter to read 400 amps in the 400 amp range, and I'm going to zero it. Then I'm going to crank the car. I know that you're reading that upside down, but you can see that my starter is drawing between 130 and 140 amps. So the rule of thumb for starter current draw is current draw for engines under 200 cubic inches should range from 90 to 125 amps. From 200 to 351 cubic inches, from 125 to 165 amps. Engines that are 360 to 455 cubic inches should only draw from 165 to 200 amps. So if your car is drawing in excess of 200 amps, you have a bad starter. One word of caution, don't crank your car more than 30 seconds. You'll overheat the starter. That concludes the video. If you found it helpful, let me know in the comments, and please subscribe.